Hi, good morning. My name is Emil Mathew. I'm a machine learning engineer at the Software Engineering Institute. This morning I'll be presenting some results of experiments done where researchers examine the evaluated LLMs on their ability to support building secure software. I might blaze through some of these slides real quick because of time constraints, but if you see one that is of interest to you, just write it down, and I'm happy to have a conversation with you on the offline. Quick question here, how many people have used LLMs to generate code? Okay, yeah, as I expected. How many people were confident that code was secure? Okay, good. I'm in the right room here. Real quick disclaimer. Fun addition to a disclaimer here. Some of this work product has generative AI. Fun 2025 disclaimer update now, which of course is unavoidable because we're talking about generative AI. Although we did not evaluate LLMs and their ability to generate secure PowerPoints, so this is all human content in here. Quick acknowledgement for some of the team members that worked on this. They helped evaluate and prepare the material that I'm presenting today. So most everyone here should be familiar with autocomplete, or its more annoying cousin, autocorrect, where effectively you provide some input, it evaluates your input and then gives you a selection of what could be a possible output. Today we have autocomplete on steroids. Effectively you can provide some input and it doesn't necessarily have to be the follow-on output. It can take that, infer some context, and give you an output. In this case, we can provide a synthetic image of a data center, one that doesn't truly exist, but was provided using a prompt. We also can give it a prompt and have it generate a sonnet, for example, like this. So if any of you are fans of the Great Bard, here, let me know if this is a good sonnet or not, I don't know. And autocompletion's already been used in IDEs for a while now. It's not new there. If you've used VS Code or PyCharm or any of these other popular IDEs, you've probably noticed that there's some like autocomplete suggestions given to you. However, now you can give it a prompt. It's not necessarily looking at what you are putting in. You can give it a prompt of what you want, and it can go out and provide you code. So this is an example of prompt to code. So of course, the question that we have here is, what happens to programmers? Is this it? Are we good to go here? We can just effectively write out a requirements and then have some LLM generate what it is that you're looking for. Well, Silicon Valley is very enthusiastic, to put it mildly. Here's two articles from this year where CEOs from Meta and Salesforce noted they observed improvement in productivity without any reduction, or maybe without some reduction or maintaining of your workforce size. So I guess it's case closed then. We can all kind of collect our CS degrees in a bin and use it for kindling for our warmth when our power bill runs out. Well, not yet. Academic research is a lot more nuanced. I'm not going to read everything here, but generally speaking, the consensus here is that there seems to be some blind spots that generative AI can create due to a combination of overconfidence or reliance by a programmer coupled with the limitations that are inherent in these models. So ultimately, we have to ask the question, where are we truly? Are we in the world where programmers are gone the way of the dodo and we don't need them anymore and maybe just product managers and designers can come up with content? Or are companies effectively relegated to churning out generative code that is fully composed of vulnerabilities from the get-go, like as a feature? So this is what the team at SEI sought to undertake, and they devised an experiment. The results of this experiment is from last year, so just keep a note here. A lot has changed, a lot will change in the world of LLMs and generative AI. So the way they conducted this experiment was they used about 1,200 code samples. SEI maintains a wiki of secure coding standards for C, C++, and Java. And this is accessible online. If you haven't gone there, I highly recommend it. It's pretty interesting. And there you can find rules for what is considered insecure code practices, and you can see an example of non-compliant code, and it gives you why the code is non-compliant, and it also gives you the compliant code as well. The models that were evaluated were ChatGPT 3.5, ChatGPT 4, GitHub's Copilot, and ChatGPT 4o. The way this experiment was conducted was there were about 2,700 runs. Each trial was a new conversation, and the prompt was simply, what is wrong with this code? And you just gave it the code snippet as well. Something to note here is that during all of these models training, the SEI wiki was available online. So theoretically, the model knows the answers to the test, and it should get everything correct if it had access to crawl the internet over the space. So here's an example of, real quick, I would also like to plug those two blogs there. They go into further detail over everything that I am presenting this morning. Highly recommend, it's a good read. It goes in, yeah. So here's an example of three models kind of identifying correctly what's wrong with this code. This is there's a C code snippet, and in this case, there was a use of invalid format strings, and all three models kind of got it right. Interestingly, the newer models seem to take it a step further, because all the prompt said is what's wrong with this code. They gave you a response and a remediation unprompted, something that is of interest, and you can think through why it is that it does that. Here's an example where all the versions missed the error. I don't have the code snippet up here. Sorry, give me a second. Yeah, I don't have the code snippet up here, but effectively it was a more nuanced use. Anyone familiar with like struct hacks in C? Okay, yeah. So it was effectively that. It was using the older way of how declaring a struct hack versus the newer syntax where you just have like you don't specify the number of elements in the array for the flexible array. And in this case, all three models said there was nothing wrong with the code. Although, again, the wiki was available and they could have theoretically had access to the answer. And here's an example where improvement in technology resulted in better results. ChatGPT 3.5 did not catch this error about reading from uninitialized memory, but 4 and Copilot did. It's good to take a second here to sort of like think through what does it mean when we talk about, improved technology. Generally speaking, in the world that we are in today, models can be improved either through their size. They can have larger context windows or more parameters. You can have a different architecture, not necessarily better, where they can use things like transformers or mixture of experts. You can have fine-tuned models that are more specifically geared to a specific task, right? Like Copilot, for example, had more code in its training data. You can also have improvements in training methods. You can also have tool use, which is coming up now. So it's good to sort of think through why it is that some models do better than the other, and what is it that makes them improved, or what is it that makes them different, especially when you're dealing with these deterministic cases. Oops, sorry. All right. And here's an example where it's difficult to truly know whether the model is right or wrong. It's not a simple, yes, they got it right, or no, they didn't get it right. Sometimes models get it partially right. So this is the compliant recommendation for the code that the model did not get entirely correct. Generally speaking, we were seeking to sort of compare the memory, and specifically for the struct. And in the non-compliant version, the struct is passed directly versus just being dereferenced, and we point to the buffer in it. So in this case, ChatGPT 3.5 correctly says, yeah, you can't compare two structs. And it said that part is wrong. However, then it goes further and starts giving inferences where there was none given. Like it imputed context. It took the term buffer and assumed it's a string. Nowhere is it a string. So it then used string compare, which would expect a null terminator at the end of your memory. There is no null terminator. If you were even to do that, you would use string ncopy, where you check n sections of the memory allocated. So this is all to say these are all examples of how, ultimately speaking, LLMs are tricky to evaluate when it comes to secure coding. Yes, they can give you right things that maybe you are able to evaluate up front. However, it might not be entirely right if you are, as a programmer, are not able to capture the nuance of what it is you're looking to do and whether the LLM truly understands that context. So here's just the overarching consolidated results of this experiment. Generally speaking, ChatGPT 3.5 fared poorly compared to 4 and 4.0. You can see that in Java, the performance between your insecure programs and secure programs was not consistent. You have 3.5 getting 39% correct versus 60%, so that's a huge delta. Additionally, ChatGPT 3.5 fared better on C++ than Java and C. So the highlight of this slide is that this is not a deterministic solution. It varies, and it varies in whether it gives you the right or wrong answer, and the wrong answer can be wrong in many different ways. And so it's important to keep that in context. Overall, ChatGPT 3.5 was found to do better in issues like finding and fixing integers, memory management, and string errors. But if you started talking about floating point errors or signals, like interrupts and stuff like that, it does not do that well. And the theory could be that these are issues that are well documented. If you were to just go on Stack Exchange or something, these are more like low-hanging fruit, and there's plenty of examples with correction over time that it can lean on, versus some of the more nuanced stuff might not make it out into its training data, and you might need to provide additional context for that. And yeah, here we see again just going from from an older model to a newer model, you can see an improvement in performance. So one of the takeaways from this is that if you're not comfortable in what you're doing, GPT 3.5 can be very good at leading you astray. You need to have the confidence and the appropriate safeguards in place to capture nuanced errors that might percolate in this code. Additionally, you need to know how to fix them. Something that's also interesting is that there needs to be more effort placed into helping humans understand how to work with LLMs. One of the things here is that oftentimes users tend to defer to AI authority. This could be an exploitation in language, for example, because LLMs can be more confident. Additionally, it can also make users second guess themselves. And so I think effort needs to be placed in remediating that. Here's a quick example of where this was possibly successful. There's not a lot of literature on this use case. It was written by the CEO of Amazon, so take it with a grain of salt, big grain. But they claim to have saved about 4,500 developer years in this particular task, where they took their existing Java 8 and Java 11 programs to Java 17. The way they did it is they first fine-tuned a model for this particular task. They also processed, they had a lot of standards written because they're a large corporation and there's a huge corpora to train models on and have them reference things. Also, they were not trying to change a lot of functionality. So you probably had unit tests in place that could help you validate whether this was correct or not. And you didn't have to rely a lot on a human to necessarily look at it. You can always check, did anything go wrong? And so in this particular well-defined context, it did do well, at least supposedly. This is an example where you can also use LLMs to validate themselves. I can talk more about this. This is a kind of involved slide, but effectively the idea is you can use static analysis tools to then help LLMs focus on things that are of interest, and then you can use that to have LLMs prove why it is remediated or not, and then pass it through a problem solver. So you sort of chain through and use tools. So ultimately, the takeaways here is don't abandon existing methods, keep your CS degree on hand, and definitely educate management and developers on this new tool. It's a new world. It's something that people are still getting used to, and it is something we have to further understand. if you do want to use it, adopting low-hanging fruit is a good way, things that are already out there. And in fact, it can help you in some cases because it can enforce good practices that are often ignored, but they're easy to do. But if you want to get into more complex systems, it's probably important to consider the investment required, for, like in the case of Amazon, to build the infrastructure around it and not just turn over an LLM and developer loose. That's all I have. Thank you for your time. Appreciate it.